got some really amazing experience. It's always really cool to have someone who's both practitioner and also you've taught, so it's like something that you don't typically see, unfortunately. But I think really cool. Just before we get started, a couple quick announcements. We'd love for everyone to get their questions ready. Feel free to start throwing them into the Q&A section or raise your hand, and then once Kristen's done, we'll get to all of those questions. Secondly, for those of you who don't know, so Promotable, we're a career accelerator focused on data skills. So I see some familiar faces, so I'm sure you guys have heard the pitch. However, for those of you who are interested, we do, of course, events like this almost every single week. So next week, for example, we have a director of analytics from Claire's. He's also really cool. We've got these almost every week, and really the goal is just to help everyone flex those data muscles, cut through some of the buzzwords, and of course, connect with everyone as well. We think that's really one of the important things that we can provide, especially during COVID, where we're all got that Zoom fatigue. So we're really happy to see everyone come back. Secondly, for those of you who want to dive deeper into data, of course, in January, we also have our next cohort for our income share agreement-based data science accelerator. It's a 15-week fully immersive program taught by practitioners. We've partnered with 1871, and of course, in addition to that, it's all backed with projects from companies. So, a full immersive experience. Anyone who's interested, feel free to come ping me after the event or shoot me an email or what have you. Otherwise, really excited to have Kristen. So I'm just going to hand it off, and then I will take it from there.
Hi, all. I'm Kirsten Fraley. I'm a director of data science, and I particularly own our data quality vertical over at Numerator. Little background, Numerator itself is a consumer data aggregator, and we make those insights from that consumer data at aggregate available to our clients so that they make better market decisions in the CPG world, in the consumer goods over at Numerator. Little background, am I getting feedback? Oh, Aaron, I can't hear you. Yeah,
that was totally my bad.
Oh, no worries. We do play in the data world. That is what our business is, data and tech. So you can imagine data quality is very near and dear to my heart, both having been a practitioner of data science and machine learning for quite a while myself, as well as now really immersed in the data quality world at a data organization. Much of our advanced analytics relies directly on this data that is our product, so it's even more salient to me. Please feel free to ask questions in the Q&A as we go. I'm just going to kind of give us a nice overview and some bullet points to kind of talk about a little bit of a framework to view data quality in terms of data science and machine learning. Okay, so I'm going to start by talking about that framework for data quality, and then I'm going to go on to kind of just data science, and particularly the data that kind of defines data science these days and what we do with it. And then particularly this idea of fit for use around machine learning itself. All right, so what is data quality? Data quality is actually an active field of research. I know a lot of us tend to think that data quality is essentially accuracy. Is the data right? But data is so much more than that. I'm going to challenge you to kind of think about data quality in this framework that is indeed kind of pulled from the academic and business literature over time to think of the data that you're working with so you can really more critically evaluate it and see that data is beyond just what is accurate or what people might think of as perfectly accurate and into something where noise around accuracy might be weighed by other factors like timeliness and validity. And in addition to that, I'm going to introduce the concept of data as a model and refer to it throughout this talk. So if you've never heard of this before, no worries. I don't know anyone else who really phrases data as a model in the same way I do, but I think it's a really, really helpful view of data for us to understand it. So first, data quality is usually considered fitness for use. All right, so that means whatever use case you're looking at, data quality is relative to that. And part of that, kind of qualitative, part of that really use case defined portion of data quality is what has kind of slowed its standardization in many ways. I know many of us in data science have used the same data set as the person sitting next to us in our open office space, or these days on our next Zoom call together. We'll use the same data set, but we use it for different purposes, and those different purposes are what the use case is. So when we think of fitness for use, you might think, okay, well, if you are designing a house and you're looking for door frames, you might kind of be okay if you have someone say height in total feet, right? That's going to be pretty good for you to choose an appropriate door frame, or door frame that someone's going to be able to get through. So that data, height in total feet, is probably going to be okay. However, if you are trying to figure out what is the smallest car someone could comfortably fit in, smallest clown car someone could comfortably fit in, you might need their height down to the inch, right? You can't be using their 6 feet or their 7 feet or their 5 feet. You're going to need their 5'6" or their 6'7". These are going to, mean different cars. I know I've put a 6'8" individual into a Jetta, and I am 5'6", and there's a very different level of comfort there. We could walk through the same door frame. So that's the idea of fitness for use. It's your use case defines how granular, how accurate, how timely your data needs to be. And that's going to bring us into this framework for data quality itself. So it is an active field of research, and people use different facets of data quality. So it's not standardized, it's not agreed upon, but I'm going to choose what are some pretty standard ones and ones that I think are pretty universally applicable, particularly for data science applications. And I'm going to note that these are data quality from the consumer point of view. Anyone who's coming from engineering might think of data quality from the producer point of view, or from data engineering, any of those fields where you're creating the data, maybe through log events and others. That's a different form of data quality, so just to kind of put that aside, there's some overlap, but it's kind of a different view. All right, so data quality as a consumer, particularly as a data scientist. You think of accuracy, yes, that's the one everyone cares about. Timeliness, validity, consistency, and completeness. So some of these are new, some of these are pretty standard. Accuracy, yes, that's the one everyone cares about. How close does it reflect that underlying reality we're trying to capture? And this is where I want us to think about data as a model. Any bit of data, any value of data is trying to capture some very, very complicated reality, some reality that might be constantly changing moment to moment. If you are trying to do sentiment analysis of individuals on Twitter, they really might be changing pretty much moment to moment. And if you're trying to do a sentiment analysis of the user behind the text, which many people are trying to model for various targeting purposes, that might change the moment they send out that text. So you kind of want to introduce this idea of accuracy, which I then kind of moved immediately into timeliness. Timeliness is how quickly we get that data. Timeliness is, do I have yesterday's data today? Do I have today's data today? Do I have last year's data today? And I know that we like to think that sooner is better, quicker is better, speedier is better, but there is actually diminishing returns on quickness. Sometimes you can get data before you can reasonably act on it. So if we are weighing, what is, really high quality, is it the quickest data we have? Where does that fall in line? It might just be if we get it within the week. The same thing goes kind of in the opposite direction. Excuse me. James, Mila. I have 2 dogs. They're adorable. They also do love post-work hours. So if you hear them or you hear their jangling necklaces, we had some issues with my headphone compatibility with this browser interface. Anywho, so timeliness is also something that really does have kind of an endpoint. Yes, there's competitive, do you have this data before them? I think many of us have seen movies or read books about, laying fiber optics. You can get, the stocks in the fastest amount of time, all that kind of stuff. Sure. But timeliness is something that is a harder end on the other end, right? This is best kind of shown in the example of a predictive algorithm that was distinctly better at predicting a critical outcome, that meaning death in a certain situation, than doctors and medical providers, which is amazing. And of course, everyone wanted to implement it. However, it took the algorithm so long to run that if that critical event was going to happen, it would have happened about 12 hours before the algorithm actually could have predicted it. So I think it's not very useful for us to have data, that someone is going to pass after they passed. And that's a really extreme example of what happens when we have data that no longer represents the world or is no longer actionable. So I'm going to think of that as, when do you fight for timeliness and when do you not fight for timeliness? There's that band, kind of golden band in the middle. And this is going to come in to our kind of big data framework, which we're going to talk about later as well. Validity. Validity is something that is often a little bit overlooked. Validity is about acceptable values of variables. Now, sometimes we do this in the data cleaning process. Sometimes we do a little bit of manipulation. We might say, I have no idea why this is, over 1.0. This should be, clearly between 0 and 1. And sometimes you see people kind of squeeze data here or there. Validity is about how much of our data actually falls within acceptable values. There is the funny data, there's the obvious outage, and all of this that might generate weird data for us. But we also see validity become an issue when we are using data, say, coming out of apps or coming out of websites and other internet forms that have constantly changing interfaces. So where you may be using data that essentially has, 4 valid options for a dropdown. Oh, but suddenly you expanded to a new state, no one told you, and now you have a 5th or 6th or 7th state, and your model's not accommodating that. And you're dropping it, or you're putting that to the default variable when you made dummy variables to represent those states, right? So suddenly everything is in Texas, which is not great, but I think most of us have seen an algorithm do before. So validity is something you actually do have to check. And it's kind of a pain in the butt the first time, but then you can automate it. And as soon as you have invalid values, just raise a flag. Just send out a message, send out an email. Consistency is one of our last 2. And consistency is incredibly important. This is consistency of the meaning of the values over time. Consistency being, this 1 and the 0, this binary variable, never switched. Well, that's great. But anyone who's worked in NLP has definitely seen that words change meaning over time. So if we're trying to do sentiment analysis on, maybe text messages for 10 or 15 years, we will notice that slang terms change meaning over time, that words gain new meaning in the social and political spheres over time, and they no longer are valid. And that's natural data, that is accurate data, but it's not the data model representing what we want. That is, now I'm blanking on an example of a slang term. I'm maybe not up to date on as many of the pop culture references as I would have been pre-COVID. But you can imagine any word that once meant chilly and now means nifty, like cool, won't mean the same thing to your algorithm, or won't have that meaning to your algorithm change unless you build in the changing. So consistency is something really tricky. That's why I challenge you to look at data as a model. And then completeness. And this is kind of our last challenge for data quality. Completeness isn't just, is there missingness in our data? Right? This is kind of the standard idea of completeness. And it is not as deep of a one as I would like you to think about. Completeness, when we think of data as a model of the real world, or some world that we're trying to capture, means, do we have all of the events that we're hoping to capture? Was there a major outage that dropped all events? Do we have all the users that we would like to capture? Do we have all the behaviors of the users? What are we missing? Like, we're always going to miss something from the real world. If we say data is a model, like all models, they're all wrong, but some are useful. And I want us to think about completeness in the same way. No data is ever complete. Not even wonderful, perfect experiments. They're not going to capture all the features that are really salient. We're going to boil them down to like 3 or 4 or 100 features that we can easily monitor with sensors. They don't have the richness of the real world. So completeness is, how much do we need to capture? Are we capturing that variation? How much of the individuals, the consumers, the items, the events, are we capturing a sufficient amount of what we want to capture? We'll also talk about how completeness also has to be considered in machine learning over space. Awesome. So that's one of the 3 prongs I want to talk about. And I do see that Luke has a question. What got me into the work I do? Well, I got into data science, honestly, just kind of by stumbling into statistics a little bit, figuring out that I really love it, falling into computer science, mathematical computer science in particular, as a result, and then just really latched onto that. Ended up, pursuing some graduate work, and honestly, all of a sudden, data scientist was a word. When I started this journey, this was not a career path. I feel like I really lucked out in that the world made a career for things that I found were really pretty cool. Data quality in particular. Honestly, I've worked on and off in data brokerage or data sales companies, and I have to say, I think the industry is fascinating. There are great, I like to think that Numerator is a great data broker. It's consumer submitted data. It is transparent. There's a lot of privacy. I've worked at another company that was all Freedom of Information Act requests and nonprofit actively submitted data. Again, really interesting, really great company. But there are fascinating data brokers out there. And it is hard not to care about data quality when you see what happens with data, because data underlies every algorithm that is automatically approving or denying you a mortgage, that is rifling, automatically dismissing or accepting your application to go on to a recruiter to see. It underlies all of the automated admissions that the next generation, the current generation are having. That is all built on data. And as soon as that data starts to get a little sticky, the world we create in there.
You've piqued my interest with the data brokers comment. What would you say from like a pure I mean, I guess I'm just a big nerd, so I have to ask what's the most interesting, I guess, data broker thing that you've seen, or something that when you're like, oh, this looks interesting, potentially good, potentially bad, but I don't know if there's one that particularly sticks out to you.
So I have a previous colleague from a fellowship who's done some really interesting work with some data brokers that Facebook was using to actually have consumers or Facebook users validate or invalidate the accuracy of the data brokers' descriptions of them. If you look at that, it is incredibly interesting to see how wrong the data is. And you start to wonder, the ads that are served to us all across all websites, not just Facebook, that rely on this really bad data. Some estimates over 40% are just completely incorrect. Maybe more than that is incorrect and or stale. So no longer correct, but maybe a few years ago was right. It really makes you wonder, all those ads we're being served, are they actually targeted at us? Would we actually want that item? Or are we just bombarded with so many similar ads because everyone has the same data on us that eventually the psychology of exposure, driving likingness, we've just been bombarded by the same thing. We end up wanting to buy because we've seen it so many times.
That's fair. My favorite is when you get things that you totally off. A number of times I've been sent emails to complete my degree when I have two of them. It's always kind of hilarious. Or the radio ads I get in Spanish. Well, my Spanish is okay, got that AP Spanish. I'm probably not the right target audience. But clearly I click something and they're like, oh, here's how you get this. So it's always, that kind of goes to some of the things that you said, right? Where going back to not just quality, but I think one of the things I think about is what are the biggest things to watch out for? The questions you ask your data. It could be kind of complete, but is this old, or does it matter if it's old? All those kinds of things. I really appreciate that you brought up.
Yeah. I'd also encourage you. So Vermont and California have data broker registries. And if you look at some of the names of data brokers, they sound very, very scandalous. And there's something to note that in the US, data brokers are defined as companies that do not have a direct relationship with the consumer. So these are essentially only websites that scrape data that you will never know about. So it's sort of like, if there was a PI tailing you, so you would never know. They're scraping data, they're following you. You've never had consent for them to produce data on you. Those are data brokers, and they sell it.
All the time.
and the names are nefarious. What they do. If you've ever had a dating website a dating app in the US, it's all up for scraping. You can find yourself on, I think, US Date or something.
Oh, well, now I'm going to try that. That is excellent. There's a few more questions that came in. Do you want to keep No worries.
This is what the headphones were for, sadly. So, don't worry. The evil mailman around the corner knows that my dog means business.
It's okay. My parents have a neighbor whose dogs bark at airplanes, and they live next to an airport. So yeah. So it could be a lot worse. Anyway. But there's a few questions that came in. We can keep these to your next pause, or we can go and send them now. Up to you.
Yeah, I can hop on these before we go on to big data. We have, valuable skills, programming background and main knowledge. I think the
I like to ask that question is like, when you look at, 1,000 resumes, right? And these all come in, what makes you say, oh, this is boring, everyone has this. And then is there ever something where you're like, oh, this is cool. Like, this is the thing that, like, maybe it's not going to be a thing that, like, you hire based on, but it's like, oh, this is at least worth the conversation.
So I've never, been a recruiter. I've never seen like the full stack of incoming resumes.
Yeah.
So I've always had a very biased sample by whoever my recruiter happens to be.
Sure.
Right. It's who they talk to. So, take this with a grain of salt.
Oh, we take a grain of salt.
But when I talk to people, what I actually look for is I almost always ask a question for someone to describe a project from how they got it, through the prep work they did, through what they actually did to implement it, to what happened after it. So, did it go into production, that kind of thing, to what lasting impact, lasting maintenance, what was the ongoing life of that project. And of course, this is biased to people who are already in industry, but not really that biased, because I've had some amazing answers from people who are essentially, right out of a graduate program or an undergraduate program. This question tells me if people know the details, if they understand why they made decisions, if they thought about and vetted the problem, or if they just took it and ran. It tells me, I don't need people who, do their own projects on the side. I don't need people who are like their hobby is their job. I think that's a really great way to burn out. And I've seen a lot of people burn out and keep on trying to switch. Data scientist, data engineer, and machine learning engineer, because they burn out because they're trying to do all that stuff all the time. I look for people who have a project that they were excited about, even if it failed. They knew why they made decisions. They knew that things didn't, go right the first time. There were discoveries to be made. That's what I look for.
I love the talking about something that didn't work, because you actually learn. At least for me, I feel like you learn a lot more from the stuff that gets fucked up versus the stuff that actually works. And usually my policy is just don't make the same stupid mistake again. Make a different one. But yeah, no, I love that, because I think a lot of people that I talk to, especially kind of fresh out of master's degrees or boot camps or what have you, a lot of it is like, oh, if I do like one more Udemy certificate or one more coding class or whatever, if I get a little better at Python, that's going to like seal the deal. And it's always refreshing to hear like that's not necessarily what we look for. It's like we assume you're good, but I can train you to code, right? It's like the thinking part that's always the challenge.
I have to agree.
To summarize that properly. And then, we can keep going through these, or you can go into your next point, whichever you're more comfortable with. I can keep talking all day long. I enjoyed the conversation.
Me too. I actually want, I want to hold off on those for a second. So I want to kind of get to big data framework. This is something that I think is really important for data science. We may not say that we work with big data. We may not think our data is big. We may not love the phrase big data at all. But this 5V framework, I think, is more reflective of aspects of data that we often end up using as data scientists, whether or not we want to say we work with big data. Sure. So first of all, I generally consider data science as the found statistics of the world. That is, we are finding data. It's generally not experimentally driven data. It's not data created for us. It is data that is helping run the back end of the website. It is data that consumers are making when they're purchasing things, that people are making when they click things, right? That's not necessarily, those saved likes, those event logs are not necessarily made for us, for a particular machine learning algorithm to, identify who's most likely to churn from our app and so that we should reach out to them. That's not what that data is made for. Not in the same way in, an experiment for fertilizer, right, is made for the reason of understanding the most effective amount of nitrogen.
Yeah.
Right? This is found data. This is repurposed data, and this is why we are sharing data and data tables with our, fellow data scientists on or across our teams. Because of that, we kind of implicitly have to acknowledge that we are really working with different data than many of our models, many of our statistical models, and many of our machine learning algorithms were specifically designed for. So it's really worth it for us to think about the type of data we're using. And I do like to refer to this 5V framework as kind of a thought experiment to assess the data we're using. So the 5Vs are velocity, volume, variety, veracity, and value. And I always write them down because there's a lot of V's, and by the time I've said 3, I feel like I've said 8. So I want to give a little background on what these are and give some hints as to why we want to critically think about them in data science and machine learning. So velocity, right? Speed. Many of us, relative to, say, people working in analytics in the 1990s or 1980s or even early 2000s, many of us are suddenly working with data that really does come in every day, right? People are, using their cell phones. They're using websites pretty much constantly. They're purchasing things online. We are getting, streaming data in some instances. We are wearing, Internet of Things. We have Google Homes and we have Siri, right? We've got lots of data that can come in lots of forms, but it can come in pretty much constantly. And the speed is something that is both exciting and puts new challenges, because that speed generally means that we are now looking at much granular data. Things like this consumer liked, something. Or this app user, liked something or swiped left, depending on what you're looking at. And that is much more granular behavior than, in the swipe example. Maybe this person, went on 5, matchmaking dates, right? Suddenly we have someone swiping, on 20 photos in a day, or 20 photos in a 10-minute period, versus, a matchmaker having, 5 individual interactions, or having end of year sales or end of quarter sales. Now we can get sales, for the morning of today because all of it's going through Square, right? We have the ability to get our data much faster, but it becomes much more granular. Because it becomes much more granular, we're much more susceptible to data drift. And that is, like, when we're measuring really small events, those small events can change. Human behavior can change. If we're measuring each individual song that people are playing on Spotify instead of the CDs that people are buying in store back in the day, suddenly those songs change really fast. People's preferences change, or they funnel really, really fast, and they get more narrow really fast. This means that drift changes really quickly, which means that timeliness, that data quality of timeliness, actually starts, it's all relative to the data we have. So you might be getting data really fast with big data or contemporary data. We might be getting it much faster, but the timeliness, the necessity for speedy data becomes much, much shorter. We have a much shorter timeline that the data is relevant and usable. That's a big challenge that we have. It also is a pretty big constraint on anyone who has to retrain models based on these granular behaviors or granular measurements. And with those granular measurements that we're getting so fast, we get this massive volume of data. And I want to take a moment and, kind of reflect on why many of us in the profession don't like to use the phrase big data. There's many reasons. It kind of became a bad term a long time ago. Of the reasons, people, some people even wrote articles about how if you have enough data, you don't need the math or science. Yes, there's a very famous Wired article Um, it's really tough. It's really tough to read now if you work with tons and tons of data and you think, no, like you need modeling, you need sifting. You don't get enough data and suddenly get perfect data because, of course, data is a model. We have systemic failures in our data that will show systemic problems. So the size does not diminish the need for quality. It does not come out in the wash. It does make challenges to inspecting the quality, from accuracy to validity, consistency, and all that. So it's something for us to really be aware of. But there's also been a number of papers now that have demonstrated that actually there are diminishing returns on the size of data that go into machine learning algorithms. So this idea of just throw all the data you have at it has been demonstrated to really not be very helpful in the long run. Having higher quality data, we'll talk a little bit about what that means for machine learning and AI and all that, in particular, having high quality data is going to give you a better model because models just don't change that much when you keep on dumping bad data at them. You have all the noise, right? It's only going to find so much relationship in there within the same type of noise.
I'm sorry, cut you off. So Microsoft knows all about that problem with their.
Oh, sorry. Well,
I said Microsoft knows all about that problem with their racist bot.
There's quite a few people who have learned that the internet is not a wonderful source of data. And oddly enough, all those data brokers we talked about before, the internet is their primary and oftentimes their only source of data. So if you think about the data that's underlying your banking decisions, remember it's the same data scraped in a very similar manner as the data that's feeding the racist bots and all of those other things we've figured out are not going to train generative language algorithms well, or others. So after volume, we have variety. And most of us who've been, practicing data science for a while have either known outright or have come to discover that we are using data from a variety of sources. This might be different apps within your company. This might be different branches of your company that you're merging data from. It's very often that you're supplementing data in some way with external sources of data. Consumer data is almost always purchased from somewhere. So if you have phone numbers, and if you ever see different formatted phone numbers, particularly in the same time period, there has been probably some mushing of outside data in to make everything fit well. But those multiple data sources, that variety of data sources, actually really brings a challenge to data quality because it means consistency over time is incredibly hard to track because it has to be consistent over time and across all of your data sources for any of the same underlying meaning. The same values have to be used. It means validity becomes trickier to track as well. So those valid values, the values that we say are okay for each feature, also become complicated. Completeness becomes incredibly difficult to understand and manage when you are bringing multiple data sources together. So a way to kind of think about this variety of data sources, I worked on a project bringing in data sources from high schools and grade schools across the country. And that sounds like, there's some basic stuff, GPA, absences and attendance and those type of things that should be really standardized. And we found out very, very quickly, lots of schools have different GPA systems. Lots of schools don't actually have a standardized way to measure absences. Some you're out the entire day, some you're out parts of the day. Some only measure absences up to a point in time, after which you're no longer you're no longer going to graduate, so they stop recording your absences. So these become really, really difficult to uncover. And because we all know a true data dictionary with a data history is incredibly hard to find, bringing these data sources together can cause a huge number of problems. Because to our machine learning algorithms, they're not noting, oh, that this data is from this source and this data is from this source, so these features have to be correlated. It's, the algorithm's blind to it all. All right, and then we have veracity. And at this point, veracity should be something that we're probably raising our eyebrows a little bit at. Racist thought aside, veracity is this idea, like, do we trust the data? If we're scraping the internet to kind of teach us how to be, a non-offensive human being, it might not, or a non-offensive machine learning algorithm, it might not be the right source of data. Do we trust it as a good reflection of a presentable human? Probably not. But that's also right. There's estimates that 2 or 5% of data on individuals becomes stale within a month. So you can imagine if your data is 4 months old, how much of your data is actually not usable. And that's just due to very basic changes in life, death, moving, marriage, births, all that. And that's just the basics. And I think if you're looking at something much, much more granular, like people's preferences for ordering takeout, Awesome. And the last one is value. Now, value, what can we change with data, right? What value can this data bring to us, which is so much the center of data science, right? Data science is the application of these advanced analytics and statistics and machine learning and AI to practical problems, right? To problems that can help, move the needle, as it were, in a corporate and a nonprofit, in a government situation, trying to change things by applying these wonderful theoretical tools. Well, the value is only as good as the data that underlies it. I encourage you to raise an eyebrow, to think critically about the value that's going to come. And before we take a break and look at these questions quickly, I want to bring up this idea of any number is better than no number. This is a phrase that gets tossed around a lot. Is any number better than no number? Has somehow morphed into any number is better than no number. And I would strongly disagree with that. And anyone who's interested in why I strongly disagree with that, other than, leading our data quality vertical, I would point you to Kahneman and Tversky. They're the winners of the Nobel Prize in Economics, despite being psychologists and an economist. I'm not sure, but they're the thinking fast and slow people. They did some work around anchoring. Anchoring is this idea that, if you give someone a number, even if it, put a number in someone's head, even if it's not, supposed to be relevant to the question you're going to ask, it's going to anchor them towards that number. If you say, did Gandhi die when he was over 100 years or under 100 years? People are just going to guess much closer to 100 than if you ask them, was Gandhi, over 50 or under 50 when he passed. And it works the same way in the business world. It works the same way across the board. If you anchor someone at a number, they're going to stick to that number. It's going to be hard to pull them away. So if that number is sufficiently bad, the decisions made off of it, even later when you give them good data, when you give them a good number, they're going to be anchored towards that bad number, that first experience of a bad estimate. All right, so a few more questions, and then I can hit the fitness for use for machine learning real quick. I happen to know that there are many academic institutions that have recently relabeled departments as data science, or data science and statistics, or data science and computer science. So it does seem to fit. I would say Social science research is an interesting challenge there. If you're looking at graduate work in data science, I think it's pretty natural to be in some of the graduate departments that it leans on. So that would be statistics, applied mathematics, and computer science mostly. If you're, looking at kind of master's level, really more applied, less the theory, less the defining of algorithms, estimating bounds, and all that kind of stuff. If you're really looking more at the applications, I think it's very natural to pair with a social science field. Now, I would not suggest, kind of just smashing the two of them together and saying, here's the machine learning algorithm, here's public policy, and just go apply the two. I do think that you really need someone who can bridge the gap between topics to define coursework that makes sense in application. We've certainly seen over the past few years that there are lots of applications of data science to fields where it's not applied in a nuanced fashion. And actions and decisions made off of it, don't make much sense as a result. The models don't make much sense with a critical eye because they didn't really understand the underlying problem. I have an undergraduate degree in psychology.
Oh, there you go. Go down the list here. There's that one. Apologies, I've kind of lost this stuff here. Let's go.
Awesome. Well, we only have 7 minutes left, so I'm gonna give some hints, particularly at machine learning.
Go for it.
It's a fun thing to think about. I know kind of everything we've talked about is very, very much applicable to machine learning very directly, and we've talked a little bit about it throughout the course of this. But I want us to think, fitness for use for machine learning. Machine learning is a very different use case than there has been for, historical analytics and advanced analytics, kind of, up until almost 2010 or soon after that. For the first time with machine learning, we are using high-dimensional data. And that's why I think those kind of 5 Vs, if you want to call it a big data, if you want to say 5 Vs of cross out big and just say contemporary data, that's why it's so important to consider that framework. Because right now we're using high dimensional data and we're using it in a way that really wasn't possible before. We are using the relationships in those high dimensions against each other. That's what the algorithms and the underlying math and the underlying projections allow us to do. They allow us to find those relationships, those underlying shapes and densities in high dimensions, and find patterns within them. That's very different than anything we've been able to do before. So in some ways, this means, okay, well, we don't need to think about some of our data quality the same way as we were previously. Computer algorithms are blind to scale. So if you're 2 inches taller than me, Aaron, and it says you're 2 feet taller than me, it doesn't really matter because the computer will never know, as long as everyone is proportionally, who's 2 inches taller than you is then 2 feet taller than you, and so on. We just need that underlying shape, those relationships to hold.
Mm-hmm.
That's something very different than what we had before, where we're often using aggregates, right? But it also means that what we were relying on before often, those use of aggregates, and we're like, oh, the central limit theorem, kind of everything, all the noise goes out in the wash. Well, once we start to have some of this noise in our high dimensional shapes, they can really start to blur some of the relationships. So having higher quality data actually becomes more of a necessity because the more noise and the more correlated errors start to occur, the more we break down those underlying relationships, the harder it is for our algorithm to find the true relationship. Instead, it will find an easy relationship that appears in our data, but not in the reality of the world. That's also, something to think about, that we have this new constraint where we need to be valid in multiple ways, right? We need the relationships, not just to kind of stack and not just to kind of aggregate work. We now need relationships between high dimensional data points to kind of morph and scale with each other, right? If you think of it as like a hexagonal, no, what are those called? Those fun physics toys that you can like pop in and pop out with hexagons in them.
Talking about, but I don't remember what it's called.
Essentially,
in the chat.
Essentially one of those, like that, the way that it preserves relationships, that's actually what has to happen in high dimension with our data for algorithms to remain resilient. And that's a much bigger constraint on our data. And now it is true that we can have noise. We can have some noise as long as it doesn't start to obfuscate those relationships and that shape. But again, we are using machine learning algorithms often because for the first time ever, we can scale individual decisions. We're not actually looking for the inference like we maybe once were looking at those coefficients. We're often looking to have a model so that for new points, we can make decisions on the fly for individual points. So this is new individual consumers that are applying for loans that are going to see an ad that submitted a resume. These decisions we're making on the fly are at the individual level. And that is something extremely new. That is something that simply wasn't, feasible to do before. But now that puts the constraint on those individual data points need to be high quality for that decision to be high quality. But particularly, they need to be high quality reflecting the quality of the training data. So systemic errors here need to be reflected there. And it becomes extremely tricky. You can imagine as soon as data drift gets in there, it puts more and more constraint on retraining models, on more and more attention to the underlying quality. New data points, new individuals, right? We are making decisions on, what ad someone sees, fine. Maybe what mortgage rate someone gets, right? That's a huge impact on someone's life. We need that data to be right. A job, if their resume actually, gets to someone. These are huge impacts. That means we need correct data on those individuals. And we have this issue. Someone brought up, a little bit earlier, are there any great Python tools or others for validation, for checking data quality and this type of thing? I don't know of any, to be honest. I'm sure there are some out there, but I would like you to think critically, and this is a great point to end on. I would like you to think critically about your data cleaning and those things that we often do to data to try to make the model perform better on the data. But in doing so, we're actually distorting the data itself in a way that no longer reflects the world well. So sure, scaling may or may not distort the relationship underlying data, but a huge issue is removing outliers. In practice, we're taught just remove outliers. They're annoying. They cause your algorithms to go here, there, and everywhere, and they're not useful anyways. In practice, outliers are often the most interesting points. They're often the biggest spenders. They are the Jeff Bezos and the Bill Gates and the people with lots of money in their pocket, or the people spending lots of money on our apps, the people who are most engaged on our social media websites. Those whales, those super users, those are the individuals that we don't want to remove. We don't want to discard. And we're so used to, the old methods that made sense for old analytics, which is so valid in many ways, but kind of old school analytics, they made sense because we weren't making individual decisions. We weren't making massive at scale decisions. So you could remove those outliers. They were kind of noise. And now they're essentially, some of the most important insights we can gain. All right. That's my hour.
That was really good. I would say one of the better, for me, more insightful talks on this topic. But I love that final piece that you bring in, because I think back to like when I had to learn math in like high school, right? And, we'll say I wasn't particularly good at it, and I got a lot better once I discovered Excel. But different conversation. But it's like those outliers, you scream them out because like the questions, right? Now it's like you think of like, what's the business question? How do I make money? How do I find insights? And now that outlier is actually really interesting. Or before it was just like, how do I make the line straight? But thanks to everyone for joining. I think we got a lot of good questions, a lot of good conversation. I'm leaving all the tables open. If anyone wants to continue to network with each other, feel free to do that. Just thanks again. Round of applause. We're going to use this little thingy here for Kirsten, because I think it was really, really good. With that, I hope to see everyone next time. Last thing is, this talk is going to be it has been recorded. It'll be on our YouTube channel. I'll send everyone an email afterwards with that, and then I will see you next time.
Thank you all so much. It's been wonderful.
Thanks.